In our last example for this series of videos, we have a situation that's pretty different from the rest of them. A fence 8 feet tall runs parallel to a tall building at a distance of 4 feet from the building. We're going to be putting a ladder over the wall, but let's start by drawing the situation. So here I'm going to just draw a tall building, and then we have the ground. And then we've got a fence that's 4 feet from the building, and the fence is 8 feet tall. You know, if I'm going to try to make this look right at all, then the height of the fence should be twice the distance it is from the building. Now, we can have a really long ladder that will go over the building and lean against, or over the wall and lean against the building, but what we want is the shortest ladder that will touch the building but get over the wall. Let me label the height of the wall. And I want you to do what you can to solve this problem. I'll give you a big hint. This is a big old triangle, and this is a little triangle. So I want you to label things, optimize, see what you can do, come back when you're done. All right, so we have a large triangle here, and using the Pythagorean theorem, I need to have L involved in some way, right? Because I want to minimize L. L is the hypotenuse of this right triangle, which has sides h and 4 plus h. So that gives me this expression, or this equation, L squared equals h squared plus the quantity 4 plus x squared. We have too many variables, so we want a constraint between x and h, so we can replace a variable, and that's going to be found using similar triangles. So I've got one triangle with a vertical side length of 8 feet and a horizontal side length of x feet. So x is to 8, and then I've got one with a vertical side length of h and a horizontal side length of 4 plus x. So x is to 8 as 4 plus x is to h. Solving that equation for h allows me to substitute out the h, and I'm again going to go with minimizing the square of the length. So I have that L, uppercase L of x, is equal to 32 over x plus 8 the quantity squared plus 4 over x the quantity squared. That's what I'm going to differentiate. I went with the general power rule, so the power rule and the chain rule. And I'll leave, you can pause this if you like, but finally I get two answers. X equals -4 or the cube root of 256. -4 has no meaning in this picture. I don't have the picture in front of us. Here, X is the distance from the wall. If it was -4, then that means the ladder is basically a dot against the building, and that's not sensical. Cube root of 256, though, is going to give me an answer for L, which is the square root of a squared plus b squared, essentially. And so I get about 16.65. So the shortest ladder is 16.65 feet long.